Hello, everyone, and welcome to today's webinar. My name is Victoria. I'm Customer Success Manager at Jmix, and I'm also responsible for the development and improvement of the academic program. So first of all, I would like to thank you all for taking the time to be with us today. Today's episode is a bit special because we are not talking about another internal CRM system. We're talking about research and laboratory operations, where software is a part of the scientific workflow and where reliability, security, and data quality aren't just nice to have. And that's why I'm excited about today's guest. Pasquale Granato is a researcher at the ESAC Institute at SUPSI, and he is building and running software that supports real experimental work in photovoltaic lab, not in theory, but in daily operations. So, Pasquale, thank you for joining us.
My pleasure.
Yeah, great to have you here. How is your day going so far? Busy lab day or a quiet one?
Well, actually, I discussed this morning a new project we are starting in the next few weeks. A new research project, always about data and measurement about photovoltaic modules. And I'm excited. I'm excited of this new project, but also my usual day is also deal with the subject of this webinar. That's it. The development of a Jmix solution for our photovoltaic lab testing lab.
Wow, I'm very happy about new project. I'm also a bit excited about this news. So thank you for sharing. Pasquale, in general, could you share your role and what your team does at SUPSI?
Uh, well, my role is I am a researcher, so I am involved in several research projects about several topics. Basically, our institute is devoted to sustainability, renewable energies, and also sustainable transportation, and also a little bit of smart cities and other things related to the sustainability related to the built environment. And in particular, we have inside our institute this laboratory, which is a laboratory that is especially devoted to testing photovoltaic modules, photovoltaic panels. So what we do is we develop new testing techniques so that the photovoltaic panels can be assessed in terms of reliability, in terms of physical quality and electrical properties. And we have this big laboratory where I think dozens of people can work at the same time on several type of tests on our module. So my daily job is to support from the software engineering point of view all these type of different projects, and in particular to support the photovoltaic laboratory.
Sounds very interesting. So this project existed for a very long time. Am I right? I would like to know in this case, how did you handle it before adopting Jmix?
Yes. The laboratory actually started, I guess, 15 years ago. And from the very beginning, I was not there yet, but from the very beginning, the laboratory had the necessity to have some software support to their daily job, to the tests. So they developed several small tools for client tools for Windows, and also a very let's say simple at the beginning web applications to support all the life of the testing. And during the first, let's say, 10 years of the laboratory, all these software solutions became more and more complex, more and more distributed. a new researcher joined the lab. They needed a new tool to a new test, and the only solution was to develop a brand new tool, usually a client tool or an integration of the web application, by the way, developed in a very old version of PHP. And so all these software solutions became quite a mess and quite a confusion of system. In addition, you have also to take into account that all the activity inside the laboratory are supported by very specialized machines, and all these machines have their software, have their interfaces, which are provided by their manufacturer. And so the initial solution before our Jmix approach was a complex mess of software and a huge amount of Excel files. You can imagine how many Excel files they shared between researchers during the project, during a research project or during a test. And this was quite an exercise of discipline to keep all these things working. And actually, I cannot say that things were not working well. They were working well at the cost of a lot of efforts, a lot of discipline, and so they at some point decided that this cannot be the uh, the future. So they at certain point decided to also with my suggestion decide to completely erase all the software landscape currently in use and develop a new solution, brand new, cutting edge with technologies that include inside all the test activities, all the module information, and all the tools they use inside a single database and a single user interface, so that new people coming into the laboratory can be engaged into this new tool. And the idea was, let's say a couple of years ago when we started, was that we created this tool to make this onboarding very fast.
Mhm.
And that's why we are now discussing of this tool, which is called, by the way, Aurora, because we had this idea of calling this with a name that reminds the first light of the day. So Aurora was a name that can encompass our aim in research.
Pasquale, thank you very much for sharing. As for me, it sounds like a classic scenario. Yes, fragmented ecosystem, outdated core that was before rising complexity. And of course, research data doesn't wait for a refactor. At that point, you clearly needed something unified, as you told.
Mhm.
So, how did Gmix enter the picture? How did you first discover it?
Well, actually, I was a user of Cuba when Jmix wasn't called yet Jmix, but was called Cuba, and I was an early adopter of Cuba, which was for me a very useful tool to basically to access pre-existing database. It was extremely useful when having an existing relational database, and I want to create very fast user interface upon this database to have a CRUD access to those data. So I was already, let's say, a fan of all the effort behind the Cuba and then Jmix. And then when was the time to choose a new tool to develop this new application? Obviously, we were faced with a lot of possible solutions. We thought and considered the classic three-tiered application with a front end developed by a front-end team, a backend, and a database developed by a backend team. But there was a little and big problem. There was no team. There was actually no front-end team, and there was just me and a couple of colleagues with all the effort devoted to actual things. So we weren't able to put efforts in front end. And so I evaluated several tools, Spring Boot, let's say alone, Spring Boot plus Vaadin, but analyzing the landscape and the scenario, the solution was pretty straightforward. The idea to use Jmix was absolutely, honestly, the one that I suggested to the board of decision, and they said let's try with Jmix. And so we started 2 years ago developing Aurora.
Pasquale, yes, thank you for sharing. I guess it helps us to understand why you chose Jmix. Did Jmix help you to keep complexity under control and stay in Java Spring world?
Yes, absolutely. Basically, the complexity of our system, of our previous system, was captured by a new model, a new entity model. So we captured all the business entity of the laboratory, and we defined them in a JMix entity model. And starting from that description, which was at the time a very basic but broad description, we started governing this complexity and constructing on this entity description all the UI and all the features of the laboratory. So
Thank you. Yes, thank you very much. So right now, let's talk about what you actually built, and if you had to explain it to someone outside photovoltaics, what does Aurora yeah, system do? Perhaps you can show a part of the solution.
yes, I can show you the main screen of Aurora, and give you a very brief walkthrough the functions we implemented. Just to give you an idea, uh,
Mhm.
the process of testing a photovoltaic module uh, is it consists of several steps. The first step is that we receive the modules that we are about to test. So the first thing we have to do is to create inside our system all the information, to store all the information about the modules, and that's the first section of our feature is the modules. So all the modules, what we're seeing here is a staging instance. The real number of modules are a very huge number. We are just seeing a very small amount of them. So anyway, when we receive a module, we define all the information of this module. So about the name of the module, the technology, all the data that characterize this module, and if we have data sheet, pictures, and all the nominal electric information, the layout, if we have the physical information, the mechanical layout, so if there are types of layers, frames, and so on, and also the amount of modules of the same type that we received, because the testing of a photovoltaic module usually is destructive. So we destroy physically the module, because it goes under several physical extreme conditions, so extremely high temperature, extreme mechanical loads. We use block of ice, and we fire this block of ice against these modules in order to assess how this module breaks into pieces. And this is one of our tests. So we include inside our system all the information related to the modules. The second part of a life of a module inside our system is to go and be tested on several type of tests, as I was mentioning. So we have this concept of matrix. The matrix, I'm opening one just to give you an idea. A matrix is a sequence of tests that each of the same type of module undergo. So, for example, this is a sequence of 7. This is a matrix containing 7 different sequences, and each sequence contains. Let me open another one. That this one is not so meaningful. Let's say this one contains these 6 tests, and each test is performed in a sequence order, so in a temporal order. So this module undergo the PMSTC test, and then if passed, a new LS test, a light soaking test, and then an electrical performance again, then another light soaking, and so on. So each module is tested, and each test is captured inside Aurora. So, for example, this is the result of an electrical performance measurement of this module, and you can see here the numbers that are the outcome of the test. These are the graphs related to the electrical performance of the module, and the user, the technical technician that performed this test can also add comments in terms of things that happened during the test. I can give you also maybe another view of our other tests. We have, let's say, for example, this one. Let's see if this is of some interest. As I said, this is the staging environment. So there are several tests that are empty. But this is just to give you an idea. Let's say this spectral response, which is usually, this is another type of test. We see the spectral response. In other words, we see how the module performs under several types of light. So we irradiate the module with a complex light that contains several wavelengths, and we measure the response, the electric response of the module at several wavelengths, and then we upload all this information inside Aurora, and Aurora perform the computation and extract all the data at several wavelengths, and then creates these graphs. Then, when all the tests are performed, we create what we call a report. And this report is actually a PDF document or a Word document that contains all the test performed, all the outcome of every single test, and final assessment of the electrical performance of the module, the quality of the module, the ability to resist to temperature, hail, snow, electrical shock, whatnot. And then this report can be attached to a research project, can be sent to one of our partners, can be part of a broader environment of testing. And one other things I want to add to this is that the set of tests that we perform is not fixed. It's not that we have this kind of tests and that's it. And that's it. We will perform forever this kind of tests. On the contrary, we continuously develop new kind of tests or improve the previous tests. For example, we developed the visual inspection and on the first year of the lab. The visual inspection is actually just a picture of the module. This is a picture of a module, and it can be a picture of the module after some other tests. So it's important to see how the module changes during the life.
Sounds
But
very interesting. Yeah. So you have to create new tests all the time. You're always
exactly. So,
evolving.
for example, we created a new version of the visual inspection which is called visual inspection high resolution, because when we started, the resolution of our camera was not so big. Now we have a very high resolution camera, so we use the high resolution camera to take those pictures, and we had to develop a new version of the visual inspection, which is called visual inspection high resolution. But this is just a very trivial example of a new test that we develop. Basically, each year we add a new way to test the modules. Also because the modules they have new technologies, they have a new solution, new electrical solution, electronic solution. So we have to be always on the same pace of the technical evolution of our modules. And if I have another minute, I will show you something that I am particularly proud of. That is the planning section of Aurora. As I said, all the modules have to be tested, but the number of test facilities, the test machines is limited inside our laboratory. So one important feature they asked us to implement, which was not available in the previous version of our system, is to schedule in the most efficient way the test and the usage of machine. So basically, we integrated the calendar system of Jmix and an external library that support us for the optimistic schedule of this testing, so that the user inside the laboratory can see this calendar that say just very easily say, if you want to perform all the tests that are scheduled, you should start today with the UV test, and then the GCO, and then the EN test, and so on, so that they have this schedule provided by the system, so that the system can suggest the best way to optimize the results of the laboratory. And this is done automatically by the system, trying to optimize all the constraints that are actually a lot to fit all the tests in the shortest amount of time.
Wow, it sounds really fascinating, and I guess it causes less headache connected with all these tests that are involved.
Absolutely, yes.
Yeah, surely, surely. Yeah, Pasquale, I appreciate you walking us through the system. It looks really marvelous. And I would like also to ask who are the main user groups, researchers, technicians, students, and what do they actually do in the system?
Yeah, and this is another aspect where Jmix came into a strong help for us, because the user of the systems, the user of the system are very broad in terms of capability and responsibility. We start with the the technician of the laboratory, and they just basically know how to move modules inside the laboratory, and so we have to instruct them to use this label, to this barcode label, to and Jmix and our Aurora prints help to print out this label, and the labels are sticked on the module, so that the technician can use an infrared a barcode reader to start a new test, to see where the modules are. And so the first type of user are the lab technicians. Then there are the PhD student and the researcher. Their aim is completely different. They want to perform the test to carry on their research. So they are not interested in all the triviality of the system. They just want a system that works and where they can upload the output of their research and then see the graphs and then extract the numbers and elaborate. And so they want a system that just works. And then we have the students. The student usually came with a fresh with coming out of their lecture of programming, of Java, database, and so we onboard them to implement a very specific set of features. For example, we have this new test, so the student can be onboarded to implement just this new test, define the constraint, define the business rules, define the entity, and then implement just this test with the rule and all the basic guidance that we give, because the system is already in place and there are strict rules. And then on top of all these people that use Aurora, there are the responsible of the laboratory, my boss, the chief of the institute, and they want to see how many tests we performed, let's say analytical data about how the laboratory is going. Are we on track? Are we performing all the tests we can? And so we have also this kind of user that are not interested in scientific data, but they are more interested in business, let's say. And so we have created several type of access, so that every user can see and work only on the specific part of the whole system they are interested in, and they cannot do any harm to the system. And there is another thing that is important. Since our laboratory is certified, so we have a certification by an external body of certification, and we are also ISO 17025. It's a number, a complex number, but let's say that we have this certification. All the things that we do on our system should be traced and should be taken into a very strict audit log. And this is a specific feature that comes basically for free from Jmix. And so we had just to enable the entity log of Jmix, and all the things that are performed inside our system is traced. There is an audit trace that the auditor can see, and so they can make sure that nobody uses the system improperly, and only the authorized people access to the relevant data. So as you can see, there is a broad type of users in our system, but we are able to give them all the required permissions.
Yes, that's a nice summary. Thank you. We have gone through workflows and user groups, and we have seen a part at least of the system in practice. Thank you for that. And you have mentioned already some of the advantages while working with Jmix, but perhaps you can mention like top three practical advantages for your team, just to summarize.
Yes, well, basically the advantage is not having to deal with the front end. We are more than happy to just describe the the um, dialogues and the screens that we want to have, and we are fine with that. We don't want to have more than that control on the front end, so we don't need a front end team. So this is a very a great advantage of using Jmix, and the other things on the lowest and the underside of the stack is to we don't have to deal with the SQL access to database structures, so we just define the entities inside our project, and all the changes, all the transformation to the database is managed by Liquibase, and this is also a very handy solution. So basically, what we want to do is just the program in Java, have control of over our development, but we don't want uh, all the all the complication of dealing with database and front end. So for us, this is the very important feature, and the main feature that we want to use for Jmix.
Yeah, Pasquale, thank you very much. And as we are speaking, of course, from the academic point of view, and mostly specifically students, what are the top three advantages for students then working with the system? Because you have mentioned that even like early students are implementing specific set of features
Yeah.
yeah, you ask. What is the best wins for them?
You know, students sometimes are involved in just pet projects or examples, so they can write a small amount of code just to have this project up and running, which does basically nothing useful, because it's just a pet project, it's just an example, it's just an exercise. Uh, we we think that students should be involved instead in a real project where their contribution can be useful for the team, and also they can see directly that their effort, their contribution is creating something that is used in production. But it's not possible if you have a very complex system with parts that are unrelated each other. We think that using our approach, our monolith approach, is the best for them, because we assign a very specific set of feature, and they can develop the feature from the bottom up. So they can define the business rule, they can model the entity, they can create all the calculation, elaboration, and all the scripting part, and then they can create also the user interface, which is very simple and very handy, because it's just a descriptor, an XML descriptor. They can define the user interface, and then they can see in a very short time all the life cycle of the feature, from the inception, from the idea to the production. So this is for our student very important, and also they are grateful for this opportunity.
Yes, it sounds really very fascinating because they have a nice opportunity to work with a real case and to see how it evolves, as you told from the very beginning.
Yeah.
That sounds marvelous. And how do you think? What do they learn faster or better because of the platform?
Uh, well, we obviously expect that they already have a strong foundation and a strong grasp of uh, all the underlying technologies and competencies. So we expect that our users are not just first year user with no absolutely competence in Java or in programming in general. We usually enroll students on the last year, so they have a strong foundation of relational database, Java. They already know Spring. They already know usually security protocols, and so when they are involved, the gap they have to fill is quite small because they have to learn how all these technologies they have studied usually in separate courses and separate lectures. Uh, they come together in a single piece of software where they can to develop all the life cycle of the project. So what they actually learn is how all these technologies, all these bits and pieces come together to create something more complex. And I guess also that the the very specific competence in Jmix and knowing all the best practices of using Jmix is something that they can useful use in their course of study and also in their professional life, because it's an asset that they can spend on the rest of their career.
Yeah, that sounds great. Honestly, I envy even them a little bit because the kind of learning experience that they are getting, like not all the students can get it really, like responsibility, real data, impact, yeah, that they are working with. Sounds great. And Pasquale, another question, like for professors who are listening to us right now and thinking, for example, we have a lab system too. What would you advise if they want to use Gmix for student projects?
Well, my first advice would be to evaluate Jmix and compare Jmix against other possible solutions, because I obviously admit that there is no silver bullet that can solve every lab project, every lab problem. Um, so not even Jmix is a silver bullet. But I suggest to consider using Jmix, and if they actually start using Jmix, another suggestion I um, very heartedly uh, feel to give is to stay uh, up to date with the evolution of the system, because we started with JMix one at the beginning of our idea, and started keeping our system up to date with JMix one without uh, doing the upgrades to JMix 2. And then we realized that this is not a good idea. Staying up to date is always the best, and usually is also very cheap if you stay up to date for all the minor releases, because migrating from minor releases to the next one is quite easily. But migrating from a major release to another one can be very complex, very costly. So if you, but probably this applies to every technology actually. But if you start using Jmix, I think that it's particularly important to stay always up to date with the release. And it's quite easy. Usually it doesn't require not even a single change, because the migration tool does almost everything automatically. So you just have to click to migrate to the new minor version, and that's it. But it's important.
Yeah, Pasquale, thank you for mentioning that. Unfortunately, you are right. There is no silver bullet for this case. But I would like to even comment on upgrading about Jmix. Like right now, our team is working on that, and we are trying to turn real migration experience into a practical playbook, like best practice guidance for different migration scenarios, like plus AI assisted approaches that help reduce the repetitive work. So you'll see more hands-on materials and webinars focused specifically on AI-assisted migration during the second quarter. I hope, yeah, this will be helpful not only for you, but also for other people who are still using the last versions of Jmix, and because we have heard about this problem, and yeah, we're working on that.
That's great.
Yeah,
That's really great.
thank you for mentioning. And if you had to summarize in general your experience, what are the most important takeaways for teams building lab or research systems?
Well, as I spoke for several
Mhm.
minutes, so it's there are as you heard a lot of things, but probably for us the best is the compactness of all our body of work. There is a single code base. The um, uh, Adding a new team, a new people, a new person inside our team is very fast. They have just to check out the repository, create the local database, and that's it. The system is working. So having this single compact code base is for us is gold. So having not to deal with the front end. I already stressed this point, but for me it's
Yeah.
very important not having to deal with the UI, because usually it's complex. It requires a specialized team, specialized competencies we don't have, and usually I don't know other labs. But I guess that also other labs are not staffed for web and UI development. They have just engineers that works on numbers, they works on the business of the lab, so they don't want to develop the front end. So for us, having this compact base code base and don't have to deal with the UI, for us is the killer feature.
Yeah. Thank you for summary, Pasquale. Thank you very much. So from my side, I guess I have no questions for today. I will check if there are any questions from the audience in the chat. So if you have any questions, please write them down. We will be able to answer them. So far, I cannot see them. Mhm. So, in general, then I would like to use this time in order to show the links how the audience can contact us. Uh, so, if you want to get the free academic license, you are welcome to contact me via LinkedIn page. And of course, to write me on my official email, as it will be seen later. If you perhaps have some concrete questions about the systems that we have discussed today, Aurora, you may contact Pasquale. Here is the info page on the screen. Pasquale, I hope you will be able to answer them. Yeah.
Of course, yes.
Yes. Thank you very much
I
for
will
your
do my best.
cooperation. Yeah. And yeah, so here you can see what was covered in general, our agenda. And once again, how to get an academic license, you may also go through our official path. So go with this QR code on our site and claim for the academic license. The only thing you need is to make a file that will prove your academic status and send to us. Afterwards, I will contact and ask just some general questions connected with what you're going to do, and then the license will be issued. Okay, thank you very much. I see that there are questions in the chat. Let me check. Any experience with AI usage? Any potential with your system? So, Pasquale, I guess this question goes to you. Have you tried AI in your system?
Well, there are two possible way to interpret this question. Use AI to speed up and help in development, and use AI inside our tool to support test and other processes. So we obviously use AI to speed up and help development on a regular basis with Jmix, and we are experimenting obviously as every developer in the world with all the system to support development, so anti-gravity, or Cloud Code, and all the other system, Windsurf, and all the other systems. So there is a great blog post on the Jmix website that I suggest all the audience to take a look if you are interested in this, because there is this very thoroughly analysis of all the possible usage of AI to support the development. And then we are also considering to integrate AI inside Aurora to help the process of testing, the creation of reporting. We are in a early stage of this adoption. We see actually some possible features that can include AI, but at the moment we are not. Our main task is to finish all the implementation of all the tests we are still working on, and give to the laboratory a very strong and reliable tool. And then probably in the next quarter we will evaluate the possibility to integrate also some form of AI inside our system.
Yeah, Pasquale, thank you for sharing. And I also have a question from my side. Have you used our AI Jmix assistant or not?
Yes, I have. Actually, as I said, I have compared the Jmix assistant with other AI system, and basically the concept, the aim is not just to use one AI, because you prefer that system. The aim is to have the best support from that tool. So we are still trying to find out what the best tool is. But actually the answer is that there is no best tool, because every day probably new models, new system came out, and so every day should be a new day in terms of a new AI support tool adoption.
Yeah, Pasquale, thank you. I hope we covered the question. And I see another question. Pasquale, do your students have a university profile, or they come from EFP? Unfortunately, I do not know the meaning of this.
Me neither, but yes, they have a university profile. They are student of our university, from our department or the other department of our university. They have a university profile, and it's a very diverse profile. It can be an electric or electronic profile, so they are more interested in the electronic part. of the system. So they want to develop the bare minimum Java that they can to complete their research or their assignment. And there are also informatics students, computer science students, and they want instead not to be involved in electronic parts, but they want to be involved in more complex development for a broad use of all the features of our platform. So in any case, they are a university grade student, even PhD students and also postdoc.
Okay, yeah. So thank you. So there is another comment from our team. I see that there are no comments so far. Yeah. Thank you. Thank you. So what was meant in the question is vocational education and training. That.
Oh, okay.
Yeah, the user has commented on that. So, Pasquale, then thank you so much for your time and for sharing
My
such a
pleasure.
clear, real world story from academia and lab operations. And thanks everyone for joining us today. If you'd like to learn more about Jmix, so feel free to reach out. I have shared already like the QR codes. I'm how to say you're welcome to write me on LinkedIn via email. So I will answer you anywhere. So have a nice day, Pasquale, and everyone.
You too. Thank you. Thank you,
Yeah,
everybody.
I hope to see you next time. Yeah, bye bye.
Bye.